So let's make sure you see the whole slide here. All right, so the topic for today is containerized architectures for deep learning. And Chris pointed already out, I had a similar talk last week at the O'Reilly AI conference in London. So we thought it's a great opportunity to also share it within this meetup here. And just a couple of words around myself. Who am I? So basically, I'm whatever you call a data enthusiast. I love working with technology. Currently, I work as a technical evangelist at AWS. And before that, I was several years at MapR, working in tech evangelism and solution engineering roles. And before that, 9 years at Cisco. And so I'm coming from a very strong data center and infrastructure background, worked up on the stack towards big data. Did a lot around containerized architectures there. And last couple of years, really, I got excited around the whole topic of AI and machine learning and deep learning. And that's really my passion right now. And I'm also very active supporting diversity in the field. So I'm a co-founder of a Women in Big Data chapter here in Germany, and I'm always happy to support diversity groups around the globe. So I actually love that hashtag Code Like a Girl that I think nicely sums it up what I'm doing here as well. Okay, so let's start right into the agenda for today. So I'm going to quickly start with a little bit of motivation, why I thought this topic is of interest, hopefully to a large audience. We're going to see what machine learning pipeline tools and platforms out there in the market, and discuss them a little bit. And then the majority of the talk really focuses on the specifics of doing machine learning on Kubernetes. I do have a nice demo with me, and you will also have the chance to play around with it yourself after the session, and then we conclude. So let's start with the motivation. So why this talk? And what I figured out being at a couple of machine learning AI conferences over the last couple of months and years is that every successful talk has to start with a quote from Andrew Ng. So here's mine. I think we all agree on the fact that AI is really here and it's transforming all of the different industries. So we're all excited to find new use cases, how to apply AI to our specific needs in the business. But looking at the business, at the enterprise machine learning, here's another quote, and I think that really nails it pretty well. Everyone has a good time experimenting and playing around with machine learning and deep learning. Most of the time, I guess, on your notebook, right, or a small development environment. But the really tough part comes when we try to deploy the models into production. So this was really kind of the idea behind this talk, to shed a little bit light on which tools are out there which might make this a little bit easier from laptop to production. So if we look at the helicopter view of machine learning, you have your training data, you train your model, and you test it with a test and validation set, and you tune a little bit for accuracy, for optimization. And basically, when you're happy with the model performance, you put it into production, you have your inference, you have the input data, you run the predictions, you check on the predictions, how good they are, and maybe tune a little bit here and there. So this is at least what many people think machine learning is, right? So we have a happy data scientist. That's actually something you can pretty easily manage on a notebook, on a small environment, and have a good time, have a good model. And then suddenly we want to push it to production. And when we look at the enterprise reality in most cases, is that it's not just a single laptop, right? And it's not just only a single system. So even before we start with training the model, we have to make sure we have the right set of data. So there's a whole process dedicated to what data do I actually have available? How do I ingest the data? I have to wrangle the data, look into it, probably do some deep analysis, have to clean the data, have to transform the data, and make sure it's really the right set of data for my use case. After that, I can start with the training. So I do a little bit of data splitting. I do what is called ad hoc training here. And then I start building the model, validate the model. And this part is mainly done in a small environment. And then when I'm ready to push to production, I have to think about, okay, how can I actually now distribute the training and run it on larger data sets, right? So this is becoming a challenge. And then ultimately the rollout and the serving part. And then not to forget, obviously, you have to constantly monitor your system. You have to log the outputs. And if you're into machine learning a little bit longer and more sophisticated, you're even thinking of maybe implementing a feature store to actually make this part easier, and also to collaborate maybe between different teams in your organization. You also have to think about hyperparameter tuning. So how can you actually find the perfect model? Then topics like data versioning and also experiment tracking are very important nowadays. You have to be able to explain how you came to those predictions, for example, and what data you use to train the model. So it's really getting tougher and tougher the more time you invest in this whole machine learning process. So looking at your enterprise environment, this is probably more than just one or two systems, right? So you probably have an environment that handles the data part. Maybe you're running on a big data platform, you're using Spark for that part or other tools. Then the machine learning part is run on a different system from probably the productionized serving environment, and then the whole monitoring, etc. So it's really a combination of a lot of different systems here. And this makes it really hard, right? So as I said, you have to wrangle large data sets. You have to find a way to kind of unify those disparate systems, to manage the whole pipeline complexity, to find a way kind of to compose your pipelines and reuse a lot of the individual steps, maybe to make it just more streamlined, and ultimately improve the portability and improve the model quality. So the happy scientist suddenly turns into a little bit more concerned team of data scientists, and maybe pulls in a couple of data engineers and machine learning engineers. So the teams get bigger, and you're trying to figure out, okay, how do I manage this, right? How do I really get to this continuous machine learning deployment cycle here? And this is really where a couple of machine learning pipelines and tools and platforms came to market over the last couple of years. And you might have heard of those, and there are plenty more. So I'll just try to focus on the most popular ones. I bet there's a new tool set probably coming out every other week. So for now, let's maybe just have a quick look at Airflow, at KubeFlow. There's TensorFlow extended, and then there's MLflow. So let's spend just a couple of minutes and quickly looking into those tools and actually how they compare to each other. So Apache Airflow actually originated already in 2014 at Airbnb. They open sourced it, I think, quite from the beginning, and beginning of this year, it actually got promoted to an Apache top-level project. And Airflow really tries to address the need to author, schedule, monitor workflows. And they do this by so-called DAGs. So DAGs are direct acyclic graphs, where you basically define the tasks of the individual pipeline, and then they get executed by Apache Airflow. KubeFlow, on the other hand, started out of the cloud native of the Kubernetes environment, when the community thought about the challenges they saw in machine learning. And Kubernetes already has solved a lot of those problems for software development and application development, being able to have a very composable platform where you are able to define basically your applications in a declarative way and then push them to production. So they thought, why not using the tools we have already and many companies are successfully using, and helping them to also adopt the machine learning part on top of Kubernetes. And we're going to touch on this part in a lot of more detail in the next slides. And then pretty new, Google released TensorFlow Extended as a platform to deploy production ML pipelines as well. And you can think of TensorFlow Extended as a collection of libraries, basically, that also can be used individually to help you with tasks like data validation, model analysis, etc., model serving. So it's a great collection of libraries you can use together, you can use individually. And for their part, to execute what they call the pipelines, which are actually also organized in those stacks, you can, for example, use Airflow or KubeFlow to basically perform the pipeline. So there's actually not just a black and white in comparing those tools. Many have like overlaps and maybe integrate one or the other. So it's really about how you can pick and choose the tools that fit your environment the best. And then there is MLflow from Databricks, which is an open source platform to address primarily the topics of experiment tracking, the reproducibility of your model, and the deployment tasks. So it's a little bit more focused on those three tasks, whereas the other ones focus more on either how to define this pipeline or how to give you the tools to basically also build kind of the end-to-end platform. So what is now the magic ingredient to kind of be able to scale from this laptop experimentation environment to basically the production enterprise environment? And many people talk of the three parts of composability, portability, and scalability. So wait a minute. When we look at those three, haven't we solved them already in one way or the other in the IT over the last couple of years? And this is exactly why we introduced and are using so successfully nowadays containers and Kubernetes. And for those of you who might not be that familiar, a couple of years ago when there was this huge trend from containers and being able to run applications in a declarative way, what made really the difference? And you can think of virtual machines as kind of computers in a box, where you really have the virtual resources of CPUs, storage, etc. You install your operating system into it, and then you install all the dependencies, the libraries, your applications, etc. So it's really a complete computer in a box. Whereas when we started using containers, it was much more lightweight. So think of containers as applications in a box. So they're actually sharing the underlying OS system, but then are able to kind of limit the resources and kind of still run independently by sharing a lot of common resources of the host. So this actually helped us to address a lot of those challenges. But then we needed to figure out a way how to actually deal with the containers, right, to manage them. And this is where then Kubernetes jumped in. And I normally ask the audience here how you define Kubernetes for the ones who have played with Kubernetes already. And what I get a lot from people is like, it's kind of the operating system for containers. It's kind of the platform that manages containers, etc., right? And you might think of a couple of definitions that you would come up for Kubernetes. And the easiest definition I found when talking to people is really, it's an API. So what does that mean, right? Kubernetes is an API and a collection of agents that helps you really to provide containers with a scheduling, configuration, networking, storage. So it is actually taking care of all those underlying tasks, kind of as an operating system. So I actually like that analogy, but obviously is kind of really an orchestrator, what we would say. And then you have a runtime that manages the individual containers. So why are we thinking now that machine learning on Kubernetes makes sense? And if you look on Kubernetes, and if you have played around with Kubernetes maybe before, it's a real new way of acting with your applications and deploying applications. So Kubernetes, for example, helps us to kind of abstract the differences in underlying environments. So, and when I talk about like applications and deploying applications, you could just think of like deploying models, right? So in this case, the application would be your machine learning environment, your models, etc. So it helps us to kind of bridge, for example, from local to a development, to a test environment, to production, or even to a cloud environment. And Kubernetes abstracts the different environments and helps you to manage a lot of the tasks correlated with it. It's also easy to extend to your individual needs. So Kubernetes has a type that's called custom resource definitions. You can think of it as kind of user-defined types as well. So you can define a type for distributed training, and you can just extend the system to whatever you need it to recognize and you want it to work with. So it's really extensible in that case. And then obviously, you're adopting some of the very successful patterns by using Kubernetes. That is working really in a microservices way. In that case, if you deploy a model in a container, that would be a microservice for you. You can deploy a second model, do some things like A/B testing, etc., where you can also use tools from the Kubernetes environment, from the cloud native environment, to also do things like traffic routing and such. And everything you manage in a declarative way, and we'll see how that works in a bit. And then there's also support for multiple machine learning frameworks. So it's not just tied to one. You can use whatever you want to pick: TensorFlow, PyTorch, Scikit, XGBoost, etc. So if we look at the at Kubernetes, and as I said before, it's really a community of various projects and a collection of projects. And there's a thing called the landscape, and I've put in here the links. You can have a look at them after the session if you're not familiar with it. So in this landscape, you find all of the collection of open source projects that help you to solve a particular task. For example, there's various options for what I said, the traffic routing. There's various options for container runtimes even, so you don't have to go with Docker, you can use others. There's various options for how to integrate storage into the environment. So a lot of projects really, which gives you the ability to pick and choose whichever helps you to address your use case and your environment. And there's also a particular landscape, that's the second link here, that is more targeted on the AI specific projects. So I would recommend really to check those out, because you can see really how quickly the whole community in terms of projects are growing. And you always have a selection of tools really to pick and choose from. So coming really to the point, why KubeFlow? And think of KubeFlow as machine learning plus Kubernetes. The goal of KubeFlow is really to make it easy for everyone to develop, deploy, and manage portable and scalable machine learning everywhere. And here's a quick overview. And as I said, it's similar to Kubernetes. It consists of a collection of different projects which help you to address the individual tasks in a way. So for example, as your environment to develop and train the models locally, they offer you a hosted notebook environment. So part of KubeFlow is, for example, a Jupyter environment. Then if you go to model training, they offer a couple of functionalities here around distributed training. You can use TF jobs. As I said, there's an integration with TensorFlow extended as well. You can see TensorBoard to visualize the jobs. There's a project around hyperparameter tuning, which is called KTEEP. You can track your experiments. You have support for model serving. And probably one of the nicest ones recently added is the KubeFlow pipelines, which also helps you really to compose the different tasks you have to perform in a visual and also in a coding way. And we'll see a picture right on the next slide here. So here you see a screenshot of pipelines, and feel free to play around with it after the session here on the environment that Chris will share with you. So here you can see how you're actually building up this pipeline as kind of a directed graph with the different tasks you want to perform. And this is the first part here, and I want to quickly touch on the three characteristics I introduced initially, why why Kubernetes and what makes it successful around composability, portability, and scalability. So looking at composability, you can use and reuse a lot of the different components and projects that are part of Kubernetes. And also, if you're building those individual tasks in here, you can think of like each individual component. It's basically going to be deployed as a container later. So it's a lot of freedom here to reuse the different components. And just as an example here, maybe there's a component in KubeFlow called the deployer. And this is actually what you can use to just basically deploy your model with TF serving later on. So, and I put on here the GitHub link if you want to explore it a little bit further. It's really this general selection of components which you can use to implement and really adapt it to your needs that makes it that powerful. So coming back to our machine learning enterprise workflow, which I introduced in the beginning here, how can we tackle this now? So if we look at where KubeFlow can help, KubeFlow can really help you with the tasks after I did the initial data wrangling part here. So you would run the ad hoc training and the experimentation, for example, in the Jupyter environment, and then to go for the distributed training and really push it out to your production environment and rolling it out and serving it, you would then use a Kubernetes platform. And you can think of, you can either run it on premises or you can use a cloud platform for that. But basically, this gives you all the tools to be able to push it to your production environment. Then for hyperparameter tuning, there's a project called Keras. And actually, to make this gap and this jump here from how do I jump out of my Jupyter environment now to the production environment, there's a project called KubeFlow Fairing. And this really helps you to use your notebook where you're writing the code, package it, and deploy the notebook basically as a container, which is pretty cool. I would strongly suggest you have a look at KubeFlow Fairing. I think this is really, really a cool idea that helps you exactly for that bridge. How do I get from the notebook to a production environment? And yeah, then you basically pick and choose your frameworks. You can use TensorFlow, obviously. You can also use PyTorch. There's the support is growing, so they're working on getting even more frameworks supported. Then for the rollout part, this is what I initially talked about in terms of traffic routing. So if you push out a model in a microservice and you push out the second one, do A/B testing, there's a project called Istio, which would help you implementing those traffic routing rules. So you can, for example, push 80% of your production traffic to the first model, and then you're introducing the second one, and you maybe test with 20% of the traffic how that one is performing. And then for the serving part, you have a couple of projects here to choose from. You can use KubeFlow serving. You can go with TensorFlow serving, or there's a project called Selden, which you can use. And then you can actually pick and choose from the broader Kubernetes landscape, which I talked about, for tools to use for monitoring and logging. For example, you can use Grafana and Prometheus here. For data versioning, there's KubeFlow metadata, there's Pachyderm. And then for experiment tracking, you can actually also use MLflow in this context. So many of those really work and support a Kubernetes environment. Then quickly on the portability. So containers, as I talked about initially, really give you the ability to kind of declaratively decide what you want to have inside of this container. So you're basing it on a, let's say, a Linux environment, a library environment. You're adding all the dependencies you need. For example, if you're working with GPUs, you want to add some CUDA libraries here and toolkits. Your specific data science, machine learning environments. And it basically packages your training code then with those dependencies and configurations. And by having this container definition, it really makes it very portable, because let's assume you're developing this on your local laptop or a development system. And then you can basically push that definition to a so-called container registry. And then from another environment, you can basically pull it and then just deploy and run it, let's say, for example, here on a training cluster. And because you specified all the library's dependencies, it's going to be running exactly the same on another environment. So this really helps you in terms of this, how do I port my code environment from a local environment to a production system. And then for the scalability part, this is really where Kubernetes is great in. So Kubernetes has a lot of features built in to really scale the underlying resources to your application needs. So this is perfect for machine learning. So let's say you train your model locally, right? And you want to actually go big now. So you want to run it on, let's say, 6 nodes through distributed training. So the data scientist here can actually define this requirement in a declarative way. And here you see a little bit of this Kubernetes syntax, which is used. So you say you want to run a TF job, and you want to run it across 6 nodes, and you also want to have the nodes to provide GPUs for this job. And then Kubernetes understands this declarative way and then provisions the 6 nodes you requested, including the GPUs. And when the job is done, the resources also scale down. So as you can see, the IT ops person wasn't even involved in here right now. So obviously IT sets up the environment before and makes sure you're staying within your maybe assigned quota limits. But then on the day-to-day job, once the data scientist was granted the access, they can really do this on their own. They don't need to file a ticket every time, maybe with IT. So as long as both obviously have worked together to set up and define the frame in which we can operate, it's really nice to be able to just push that and have the underlying platform give you the resources. And with that, I think enough talking here. I'm gonna switch now to a quick demo. And I've recorded the video here just before this talk. So you can see here how the Kubernetes dashboard looks, for example. So I've set up Kubernetes here. There's a lot of different individual components with it. So don't get scared by that. It's part of the system, but actually it's not so much interesting for you from the data science perspective. I just want to quickly show you how it looks. I installed KubeFlow, so all the components are also installed in here. So maybe move that away here, yeah. And then what I'm doing here, I'm switching basically to this KubeFlow environment. And as I said earlier, you see here the different components, pipelines, Katib, and the notebook server. I created a notebook Jupyter environment here. I'm jumping in here, and I'm starting a notebook, the Doppelganger app. So in this case, what we want to do is doing some image similarity search. And you can spot by the picture, there's a saying that maybe dog owners sometimes look a lot like their dogs or the other way around. So we want to prove this here and see if we find the perfect dog for me in this case. So I'm importing a couple of libraries, nothing fancy here. I'm using the Stanford dog data set. So I'm pointing it here now to those dog images. I'm gonna set a couple of parameters to train the model. So I'm scaling the images basically to 299, 299 here. I'm creating image data generator, which basically gives me this flow of images out of the directory. And I can see here, I do it on a batch of 200 samples. And I just show one example that is me. So I'm going to use my picture here to basically find the perfect dog that matches my picture. And the way I do this here, I'm using a pre-trained model exception just to make it easier. It's pre-trained on the ImageNet weights, and I'm gonna calculate the so-called bottlenecks. And this job runs for a while, so I fast forwarded that. And bottlenecks are really the last layer before we go into the fully connected layer in my neural network. So we can actually visualize it here. So that's what a bottleneck would look like for this first picture. And then what I'm doing, I'm calculating the distances between those images. And this is basically how you can implement the image similarity search. So here we can visualize how the Euclidean distances look like. And I'm setting a couple of parameters here when I have like 5x5 output, and I'm defining my image search here. So I'm pulling in this calculated distances, and then I'm plotting them, and I'm giving them my first picture here. So I'm changing that to me. Yes. Quick check that I grabbed the right picture, and the rest of the pictures are really the dogs. So it calculates the distances here, and as you can see, it's okay. There's always room to improve the model, obviously, but I think it's quite good. So the majority of dogs actually are kind of black-white dogs, probably. So it optimized because I passed on a grayscale image, so I can basically help there and actually do grayscaling of all the dog images to kind of have better samples here maybe. And yeah, as kind of a hobby data scientist, I get swept away here. So you can also do some funky stuff and calculate the average phase with eigenphases. So if you want to play around with that, so it's the dog is coming through here on this picture, I think. But back to the actual idea of showing you how you can build containers. So what you see here is basically I experimented locally in this Jupyter notebook, right? And what I'm doing now is I'm taking the code that I developed in the steps above, and I'm putting them here in a Python file. So this is what we're seeing here. So it's basically the same code, just make it executable here for a Python environment. And then I'm creating a so-called Docker file. And this is what I said earlier. So you're basing the Docker file, let's see here, on an environment, on a Python 3.6 image. I'm giving it access to the images, the dog images, and I'm also passing it this Python script. And then for Kubernetes, I define a so-called YAML file. This is the declarative way. And I'm pointing it here to this container. So basically, I fire up a command to Kubernetes using the API, and I use here a command that's called kubectl. And I'm firing up this YAML file. And you can see here, it says the pod is being created. And I can switch back here to my user interface. You can also obviously do all this per CLI, which is much nicer, but sometimes I prefer the visual way. So I'm going to show you here. Here is the pod, double-ganger train. So basically, we just created a training job on the Kubernetes cluster. So this is executing now. It's spinning up the container. It's loading the data, and then it's executing the training. And if you go into here, you can see the logs, what's happening inside, and you can see it's executing code, basically what's written in the Python code file. And you can see training is happening here. So instead of training this on my notebook environment, I'm basically now training on the big infrastructure that Kubernetes gives me. So going back into my Jupyter environment here, I can also sneak into the logs from here actually. So I see the similar thing here from my Jupyter notebook. So as a data scientist, you don't even have to jump obviously into the Kubernetes environment. That's pretty much abstracted from you. But also if you want to go there, you can sneak in here. Okay, so that was training. So let's do the same exercise basically for the inference part. So again, I'm writing here my Python code. So I'm creating a class called my doppelganger model with a couple of functions here, and most importantly, the predict function, obviously. And again, I create a so-called Docker file, which says, okay, install the requirements, copy in this Python doppelganger model code, and then expose a port here and run it. I'm using the Selden project here as a Selden core microservice. I'm wrapping the thing again in the YAML file, so Kubernetes can actually execute. And you don't have to basically write all those templates. So you can basically grab a couple of existing ones and just optimize them, or you use services, as I said, like KubeFlow Fairing, which actually does the job for you. So this is really kind of bare bones here, showing you manually how it works, but you don't have to perform like all of those steps later on. So I deployed the inference pod, and to test it, we can basically run a curl command. So the pod is created on Kubernetes, and it's giving me a REST API. So I'm firing up this curl command, and I get the prediction results. And I'll just grab here one image that I get as a response, and you see it's this lovely husky image. So with that, I hope you got a little bit of understanding how the components work together, how I can go from my notebook instance where I experiment to using tools like containers and Kubernetes to kind of push the things into a larger environment and also ultimately into production. Just a quick wrap up here, my doppelganger app, and what we did here was the image similarity search as an easy example of a use case. So quick recap, what happened more here on the architecture side. So obviously, I already had Kubernetes and KubeFlow set up. So that's obviously the prerequisite. In my case, I had 3 worker nodes, so 3 physical underlying servers to run it. Obviously, in a production environment, you can have as many as you want, either on-premise or, as I said, you can use cloud services. So you don't even have to take care of managing Kubernetes yourself. And then basically with KubeFlow installed, you get your Jupyter environment. So as a data scientist, you're pretty familiar with Jupyter, I guess, and you can still stick to your known environment here. And then you start experimenting, right? You start playing around with the data sets, with the models. And once you've come to a good state, you basically create the Python code and a Docker file for the training job. And then you can use that to fire it up against Kubernetes and run, for example, distributed training on the environment. And then once you got a trained model, you would then develop the Docker file and build the container for the inference service. And then you can basically fire that up against Kubernetes again to push it into production. And you can think of those as the single microservices, right? So you have like model A here as one service, and maybe a couple of days later or overnight, you're training and you're testing a new model the next day. So you deploy a second environment here, and then you can actually use services that I talked about earlier for traffic routing, which would be, for example, Istio, which you could use to shift traffic in the way you want. And then it's exposing the microservice and your model as a REST API. So you can easily use a call command to basically test your predictions. So this is really the KubeFlow way of doing things. And as I said, there are like many different ways to achieve this. You don't have to write those YAML files yourself. There's a lot of things being worked on to kind of automate this. So really, as a conclusion for my talk, what I want to leave you with is really the platform matters, right? And I talked to many people that are saying and asking, like, how do I get from nowhere to somewhere, right? And how do I choose which framework, which platform, which tool set to build my environment on? And it's not going to be the same for everyone, obviously. So what I can leave you with is really, once you look at the different tool sets there and platforms, check for composability, portability, and scalability, right? How easy is it really to reuse existing work, which you're doing maybe in a small environment, to reuse and push them into a production environment? It's not black and white. So in some cases, you might combine a couple of those tools, as I pointed out. Maybe you want to start with TensorFlow extended, but you want to run execute the pipelines with KubeFlow pipelines, especially if you're pushing out to production, maybe because your company has already standardized on Kubernetes for application rollout. So there's a lot of like different components, obviously, to think about, but really have a look at containerized architectures, as I think it proves a lot of value in especially how to scale in production, and obviously just start building, right? Try using the different demos and components here and see which tool really addresses your needs the best. And here's the link to my GitHub. So if you want to play around with this little doppelganger app, please, disclaimer, it's not a production environment. Obviously, it's just a little demo script, but feel free to use it to play around. And if you're want to look into how to do image similarity, for example, or go into more into those eigenfaces, I think that's kind of a funny thing as well. If you like it, please start the repo as well. More information, here are the links to KubeFlow, to TensorFlow Extended. And in my case, I built everything using Amazon Elastic Kubernetes Service. So the Amazon hosted Kubernetes environment, but obviously the power of Kubernetes is that you can run it anywhere. But if you're fancy and want to look into it, there's actually a pretty nice workshop online, which you can use just to understand also the concepts of Kubernetes a little bit more. And also a lot of samples out there, which you can just have a look at if you want to. All right, and with that, thank you very much. And I saw there were a couple of questions coming in. I can probably have a look at them. And I'm handing back over to Chris, and I think he wants to show you actually how you can get some hands-on here as well for this part.
Hey, okay. Thanks, Antje. That was great. I want to send you guys away with, oh yeah, so I think there was a question about Pachyderm, if there's any more info on that. And also there's some questions about the recording. Yeah, so I posted in the chat all the URLs. So it's slideshare.pipeline.ai and then youtube.pipeline.ai. We'll post those there. Yeah, Antje, do you have any info about the Pachyderm stuff, or maybe just point them to the Pachyderm docs on that?
Yes, so I haven't really done much with Pachyderm yet. So yeah, I would best refer to the online documentation there. Or if you have any more insights from your work, maybe.
Yeah, I know that the Pachyderm folks are paying attention to KubeFlow pretty closely, and specifically around the ML metadata store. So, and I think there's even a working group around the ML metadata for KubeFlow that might be, yeah, that like could be worth checking out and paying attention to. Let's see, what does Kubernetes pipelines add on top of KubeFlow? So when people talk about KubeFlow, they typically are actually talking about KubeFlow pipelines. It's kind of the most visible part of KubeFlow. It's the one that has the most mature UI. So you could use KubeFlow without KubeFlow pipelines, but it's more often than not that you're actually using those pipelines. So it's either Jupyter part of KubeFlow or it's the pipeline part of KubeFlow. And so pipelines gives you a domain-specific language, DSL, to build pipelines, to deploy pipelines directly from Jupyter notebooks. And the whole point of KubeFlow is to build pipelines. So if you're doing it from Jupyter, if you're using Faring, which can take a Jupyter notebook and then convert it, or if you're going to use the KubeFlow feature store that's called Feast, you have pipelines that are pulling from the feature store and then training. So really KubeFlow is KubeFlow pipelines. Okay, and I wanted, so I added Antje's doppelganger stuff to Community Edition. So some of you might already be familiar with this. And let me actually share my screen real quick and I'll show you guys. And then I'll post the link here. Let me share real quick. Okay, so Community Edition, if you're not familiar with it, you could just go to community.pipeline.ai. That'll redirect you, get you over, and it's a live version of basically what like Antje was showing before. She was running hers on EKS, which is the Amazon Kubernetes service. And let's see, so Jupyter, clicking into Jupyter Notebooks, there's now a doppelganger directory and has doppelganger A, that's the notebook that she was showing. And this is actually live. So this is a shared environment. I've got it all set up right now to run kind of once through. Some of you guys, if you're out there, if we're all hitting it at the same time, it's going to be a disaster. So try to check it, maybe later today. But this is the live version, and this is the exact thing that Antje was running. I think maybe a slightly different picture, possibly. I can't remember which picture she used, but these are the dogs that look like her. And then let's see, doing a PCA to pull out principal components, looking at the eigenfaces of these dogs. It's kind of funny. And then showing an average face, not very useful, but could be used as a feature engineering step. And then here's some of the training code that I believe she showed you earlier. This is using the Stanford dog data set. I was kind of cracking up because of course Stanford has a dogs data set. And it looks like a Stanford website too. No like images or anything, just a bunch of text and a bunch of links and good text and things. So this is a whole data set. There's about 800 megabytes of images, all kinds of different species and breeds. So let's see, back to this. We were primarily focused on image similarity here and then deploying the model. So this is the inference code here. We also have the training code up here and the training deploy.yaml that Antje showed earlier. So this is the live version if you guys want to pull it down and actually try it, or go to her GitHub and pull it down directly into your cluster. We're using Selden for the prediction, which gives us A/B testing capabilities. And I don't think we're doing an A/B test in this notebook. I think we're just doing a simple REST endpoint. And this is the live endpoint that was deployed. And here it's actually returning some of the similar images. I think these are referencing a cluster that is been terminated, but this gives you the idea. So this was trained earlier and then has some older URLs here for these images. So I think that's it. I'll post this afterward and post all the links to the meetup and to the webinar. And let's see if there's any other questions. Let's see. Yeah, so if there's not any other questions, I'll give it like another minute here, and then I think that's it. So let me post the link here to community. And we'll be posting everything. We'll post the video slides later today. And thanks everyone. Thanks, Antje.
Sure, thanks everyone for joining.
See ya.